The general idea behind this web service is that it uses OpenCV's deep learning framework to allow the YOLO algorithm to be run. It creates the neural network by reading in the weights and configuration, and also loads in the names to get the list of objects that can be detected. This image is then loaded in with IMD code, and it is converted into a blob that is then fed forward through the neural network to get the output. The output is a two-dimensional array that contains every detection, so a for loop is used to get the array of a detection, and from this the class ID and confidence can be obtained. If the confidence for this detection is greater than 0.5, it can be assumed this is a correct detection, and the object or the detection is then added to the list of objects. At the end of this loop, this is then returned. The objects are then returned in JSON format. Multi-threading was not explicitly designed in this web service, which could be a potential flaw, but the post method allows threads to call this web service. The general idea of this containerization is that it loads the iWebLens server script and all necessary files onto the Docker image, and that's basically what this Docker file does. It adds the server script to the image along with the configuration, weights, and names the code will need. It then installs all relevant dependencies that the script needs to run, and it finally runs the script on the image. We can see the nodes of the cluster by using this command to then see that there is the control node and there is the worker node as required. Cube CTL cluster info then gives the IP and port that the cluster is running on, and it also shows the location of the DNS server. We can then see the deployment, which has the main characteristics of the labels, which matching with if matched with a service that has the same label will run that service, as well as the number of ports and the container port. We can then see the corresponding service configuration that then shows the same label matching with the deployment file, as well defining the type of node port, as this is one of the two that can be accessed externally, and again defines the port the new service will run on. We can build the Docker image by using the following command, and build it using the Docker file we saw earlier. We can then use the following command to load our Docker image on to the cluster, which it is doing right now. We can then see the public IP of the VM, and here we can see the port chosen, which in this case was 8080, which is a well-known port, so it's less likely to have conflicts with Nectar. We can then use this command to get the pods in this deployment. By doing that, and all 3 pods are listed. Unfortunately, I was unable to figure out how to run it externally, but running the script inside the VM with 4 threads and 3 pods, it's like this. From 2 of the pods executions, you can see here that the loads are fairly similar. If you look closely, that they use about the same requests.